So this is the DEB, paper 1, question 8. A right circular cone is inscribed in a sphere as shown. The sphere has a centre O and a radius of 12. So there's my centre. And that's 12 there. And that's 12 there. And, you know, obviously, you blow the 12s there if you want, even an infinite number of radii. A is the vertex of the cone. Okay, stop at the cone. B is a point on the base of the cone that touches the sphere. Okay, and C is the center of the base of the cone. That's grand. So that means BC is the radius of the cone. Let OC equal to X. Okay, I'm just going to put that in there. And find BC, the radius length of the cone, in terms of X. Right, so that means that I have a right angled triangle. This is called X. This is BC. And this is 12. So I'm going to do it by Pythagoras Theorem, where we say that 12 squared is equal to X squared plus BC squared, which means that's 144 minus X squared is equal to BC squared. And then that just leaves me to get the square root of both sides. BC is equal to the square root of 144 minus X squared. Okay, not bad. Junior cert question there, really, just the use of Pythagoras' theorem. Show the volume of the cone is equal to this. So volume of a cone is, go to your log tables, 1/3 pi r squared h. Not sure they give me enough room, but anyway, I'll go for it. 1/3 by pi by the radius of the cone. So the radius of the cone is BC, okay. That's squared times h. So what's this? This is 12 plus x. So the height of the cone is 12 plus x. Okay, so then that's 1/3 pi. This squared is 144 minus x squared times h. Okay, that's it. I just need to make it look like this. So I guess I can factorize this. It's the difference of two squares. I'd end up with 12 minus x and 12 plus x. So that's that factorized by my 12 plus x. And that's how I have this. Okay, so multiply top by top, bottom by bottom. That's pi over 3. 12 plus x squared by 12 minus x. Hence find the maximum volume of the cone. Well, if you multiplied that out, that would be a cubic. Starting low, ending high, because I think it would be a minus x cubed. All right, so sorry, I'm just drawing that maximum here. Realistically, we're looking for a turning point. So a turning point. How do I find a turning point? I'm going for differentiating. So in this situation, this is the volume. I think I'll multiply that out. Pi over 3. That's 144 plus 24x plus x squared times 12 minus x. I just find this easier than maybe doing the product rule. I think this would be easier. So what would that give me then? Pretty sure when I clean all that up, 144. Minus 24. X. No, because I'm to multiply that out. So that's 12 times that. That gives me, sorry, 1,728. Yeah, so I think when you clean all that up, multiply it all out, should get that. And then top by top, bottom by bottom, 1728 pi all over 3. Calculator, see if that simplifies. 728 divided by 3. Yeah, so that simplifies even more. So when I multiply that out by that, I have 576 pi. That by that is 144 divided by 3 plus 48 pi times x. So remember, pi is just a number. You know, so any number differentiates to 0 when I go to differentiate it. Here I'll bring the 1 down in front of my number and subtract 1 from the original power. Minus 4 pi x squared, and then this is minus pi over 3 x cubed. Sorry, there's no need for the bracket there. Okay, now I'm going to differentiate. So that's the volume, then now that I have it a bit cleaned up for myself, dv dx. Now, why am I looking for dv dx? Well, when, right over here, dv dx equals 0, I have a turning point. So that differentiates to 0 because it's just a number. That differentiates to 48 pi. That differentiates to minus 8 pi x. And that differentiates to, bring the 3 in front, simplifies pi x squared and minus pi x squared. Might look different in the solutions because they might have cleaned it up the way I did, but this is the way that I'm going with it. So now I let my dv dx equal to 0. I'm going to divide by pi. I'm going to factorize this or throw it into the minus b formula. When I do, I'll end up with 2 answers for x. Minus 12, I think, is 1, and 4 is the other. Is it possible that minus 12 could be x? No, x is the length of a line off back up further. So I'm going to cross that one off. Not possible in this situation. So x is equal to 4. Right. Now, I didn't know which of those is my maximum turning point. I might have an idea from my sketch, but I need to just be absolutely sure. So what I'm going to do is I'm going to get the second differentiation, and if I get my second differentiation and sub in 4, so my second differentiation should be, if we're looking for a maximum, it should be less than 0. My second differentiation here should be less than 0 when I sub in x is equal to 4. So let's get this differentiated a second time. So that's a number, turns to 0, bring the power in front, subtract 1 from the original power, minus 8 pi minus 2 pi by x minus 8 pi minus 2 times pi times 4. That's minus 16 pi. That is definitely less than 0. Therefore, I have a maximum turning point, which is what I wanted. And now that I know that x is 4, I need to find the maximum volume. So when x is 4, I need to sub that back into my volume. All the way back up here. Obviously you can do a cleaned up version of it. So when x is 4, sub it in. So I have pi over 3, 144 plus 24 times 4 plus 4 squared. I definitely don't feel like I have enough room here. 12 minus 4. And when you sub all that in, you end up with 2048 pi over 3, and it's centimeters cubed because it's volume, or units cubed, but up here they've said centimeters, so centimeters cubed. Remember, they'll deduct a mark if I don't have my units. So these section B questions are generally longer, so now we have a B part. A water trough of uniform cross-section with length L is shown in figure 1. The trough has a capacity, so that's volume, and the two ends of the shape are of an isosceles triangle, grand. The dimensions of the internal cross-section of the trough are shown in figure 2. Show that the internal surface area of the trough is equal to this. Okay, so here we have an isosceles triangle. Split it down the middle if we want. Have our right angle triangle, and so at the internal. So if I'm looking for the internal surface area, then okay, it looks like I need the area of this end. I'll double it because I have another one at the other end. I'll need the area of the top and the slanted side here and the other slanted side, so I'll double that as well. Right, so let's just work on getting this. How do you get the area of this triangle? Half base by perpendicular height. I need to work out the perpendicular height here. I'm going to use Pythagoras Theorem. That gives me, so that's 8x, which means that's 4x. So half. So I'm just getting the area of this at the minute. Okay, so half the base by the perpendicular height. I don't know. How am I going to get the height? I'm going to do it by Pythagoras' theorem. So that is 5x to be squared is equal to 4x to be squared plus something squared. And I'm going to get you to work that out. When you work it out, you know, like you just get used to seeing Pythagoras' theorem, so 5, 4, and then this would be 3, or you see other ones with like 13, 12, and you know, ones you just get used to seeing. So I know this is a 3x squared. sorry, a 3x here. So you just work that out using Pythagoras Theorem. So half base by perpendicular height gives me 6x. That's the area of this half here. Double it to get the full thing, so that's 12x. So here we have 12x, and I have another 12x at the back. So now we have 24x, and that's my two triangles. What else do I need? I need this, which is L by 5x. Okay, that's the side one. And the other side will be the same. L by 5x. And then this here will be 8x by L again. Top rectangle. Length by width, L by 8x. Now we have a bit of a problem here because it says show the internal surface area is this. So, sorry, that's an x squared. So that's 24x squared, apologies. So I need to go back to the question. I need to see what else they say. They said the capacity, so the volume, and I mentioned that. I said capacity is volume. So I'm going to have to work with that, hopefully be able to figure this out. I'm going to just go down a little bit further here onto the page. So the volume is 112.5 litres. Now I've been working in centimetres here, so I really need to change that. So that is 0.0 centimetres cubed. So the volume is that. What's the formula for the volume of this shape? So this is a prism. It's a uniform prism. And okay. So solid uniform prism here. And uniform just means that when you chop it up, it'll be the same shape over and over and over again. And like when I chop my shape up over and over again, kind of like I just slice it off like it was, I don't know, cheese, a block of cheese or something, I'd have a triangle over and over and over again. So if you want the volume, it's the B, which is the area, the area of the uniform shape, multiplied by the height of it. So it's the area of the uniform shape by L. So I'd have to like stand that up so I can call it what it looks like inside in the log tables. So that's equal to, we said the area is a 24x squared times L. Which means if we isolate L, that's equal to 112,500 divided by 24 is, I'm going to put it in as a fraction, so that is 935. No, sorry. So what did we say this was? We said it was 12x squared. Sorry. The reason I said 24x squared up here is because I have two triangles. So it's just the area of this shape here multiplied by the height, I guess, if we stand it up. That's 12x squared by L, which means that we have 9375 when I divide both sides by the 12 and the x squared over x squared. So now I can go back to here, and anywhere I see an L, I'm going to replace it with that. So the area of the front is 12x, the area of the back, sorry, 12x squared. So the area of the front is 12x squared, the area of the back is 12x squared. That's where I've got my 24x squared, plus L times 5x. And we've said L is 9375 over x squared times 5x, plus, again, because I have two sides, and then plus L 9375 over x squared times 8x. Now, when I work all that out, I end up with this. Yep. So just clean that up and you have what they've told you to make sure that it's equal to. Right. Next bit. Find the volume of X for which the internal surface area of the trough is at a minimum. What the volume, no, the internal surface area we've said is this. They've given it to me, the 24x squared plus 93750 over x, or times x to the power minus 1, whichever way you want to do it. So that's the area. We want, I'm going to differentiate it, let it equal to 0 because that's a minimum turning point. We're looking at a U-shaped here, I think. Oh, actually we might not be because of the x to the power minus 1. So if you want to, you can give a graph of that to yourself, or, you know, now obviously not inside the exam, but look it up on GeoGebra to see what it would look like. But we're looking for the minimum surface area. So we differentiate, we end up with 48x minus times x to the power of minus 2, which is same as over x squared, equals 0. So we let our differentiation equal to 0. Multiply across by x squared, we end up with 48x cubed minus 93750. Well, I'm going to just bring that over. Divide by 48. 93750 divided by 48. Doesn't work out that nicely. Get the cubed root of both sides, and 12.5. And I get the cubed root of both sides there. And again, I need to put in my units. If you want to be absolutely sure that it's a minimum turning point, then you need to do your second differentiation and ensure that when you sub in your 12.5 into your second differentiation that you get greater than 0. But they have asked me to verify my answer, which means that I will need to throw in the 12.5 into, find the value of x at a minimum. well, verify my answer, that should be doing my second differentiation and showing that when I do that and sub in my 12.5 that I get an answer greater than 0, so the minimum area is when x is at 12.5 centimetres. So I'm sure you can do that to get your second differentiation. I've done that in a question there already previously. Just, you're looking for, last time I was looking for a minimum turning point, no, maximum turning point. So I was looking, when I subbed in my second differentiation, I was looking for less than 0. Now I'm looking for a minimum turning point. So when I sub into my second differentiation, I should get greater than 0. Hence, find the length of the water trough. Well, what did I know that L is equal to? L is equal to 9375 over x squared. And what do I take x to be when it's at a minimum? We said x is 12.5. Throw that in and you should end up with, I think it's 60 centimetres. And then water is poured in at a rate of 0.2 litres per second. So that's dV dt. I think I can already see where this is going, 0.2 litres per second. Find the rate at which the depth or the height, so that's dH dt, is, right. And then, so we're looking for the volume of one of those shapes. So volume is the base by the height when you look at it here, sorry now. So my base is a, you know, if I'm going to stand that up on its side, it's a triangle, and God, my diagram is going to be terrible here, but anyway. So I think I have it actually on its side, you know, flat there, but if you stood that, if you stood that up, oh, I'm terrible, I can't draw that. If you stood that up, a Toblerone, and you stood it up, the base is the triangle, and the height is however tall the Toblerone bar ends up being. And I think we have that done. No, we haven't. We have the volume is equal to 12x squared times L. So in this situation, like, you can't differentiate when you have two variables. So I'm going to have a good look at it. And what do I notice is that, I guess, you know, when I have it, just now, water is poured in, right? Okay, so the trough. So the water will be a certain height. And we're going to have to use similar triangles in order to get the height. This is very tricky because I wouldn't expect you to know that, but I do hopefully expect you to know that you can't differentiate with two different variables here. So we're going to have to do something. So even if you just got as far as here, realize that it was a rate of change question, that would be brilliant. This is one of the hardest questions that I could, you know, you could come across to do at rate of change. So we're going dipping into paper 2 or similar triangles. What do I know? So this is 4x. Now, so what am I'm doing? Just looking at this. We'll call this y. We know that this is the radius 4x. And we know that this is 3x, the whole height. And h is what we're looking for. So what can we have a look at? We have figured out Now this seems to be a little bit unclear. Do I go back? I guess it's all part of the same question. So now I'm continuing on where the trough is at a minimum. So we're saying x is 12.5. So y over h is equal to 4 times x over 3 times x. And the x we're saying, now they should have made that clear. Saying continue on and use that x is 12.5, which means that y over h is equal to, what happens when I multiply that out? 50 over 37.5. And what are we going to isolate? We need to isolate the y. 50h over 37.5. Now, what is y? Y is, oh my God, this is such a tricky question. So y is now, let's say, the base of my full triangle. My right angled triangle. So I need to double that because my shape is actually like this. So that's 2y is going to be the same as 100h over 37.5. And now we're getting the area of this, which is half the base. So it's half of the 100 h over 37.5 times the perpendicular height, which we've called h. Finally, so now that gives me 50h squared over 37.5 is, no, what have I just figured out? I figured out the base. What are we looking for? We're looking for volume. Volume is base by perpendicular height. Oh. Right, this is my problem. I never looked at this back here. We're still looking at the fact that if x is that, then L is this. Okay, they definitely should have made that way more explicit, that you're to use your information from back further, because it should say when the internal surface area of the trough is at a minimum and water is poured in, they really need to make that clear. Okay, so my, do you know the way it's the B by the L or B by H? And in my situation, they've called HL. Well, L is 60. So that is 60 times, and my base is a triangle. I've just, without even knowing that I was doing it, have worked out the area of my triangle for where it's full in terms of h. So that's 60 times the 50 h squared over 37.5. Multiply that out and you can end up, I think you end up 80 h squared. So the volume finally is 80 h squared. After all that work, we want to differentiate it because the variable is h. We get dv dh is equal to 160 h. And then there's my 3 pieces of information. So what do I need to do? I'm going to go dv dt is equal to, there's my 3 pieces of information. dv dt is equal to dv dh times dh dt. If I look at that, that makes mathematical sense because they would cross off. So dv dt is 0.2, dv dh is 160 h times dh dt, which is what we're looking for. Bring that over, becomes division 0.2 over 160 times h. In this situation, they've told me that the height of the water is 5 centimeters. And when I work all of that out, I end up with a quarter. And then what is my unit? Find the rate of the depth. So height is centimeters per second. So that should be the end of the question. Yeah, long one.